Fusion Mobile, quality e-learning experience on the go.
Welcome to Fusion Mobile e-learning clinic. I am Sonia Olaoluwa. I'm taking you to the physics course, and how about to look at the topic heat energy. In this topic, we'll be considering the concept of heat and temperature, effects of heat on matter, measurement of temperature, kinetic molecular theory, thermal expansivity in solids and liquids. Of course, we'll also consider state of change, and finally, heat transfer. So, let's start with the concepts of heat and temperature. What is heat? Heat is that feeling that you feel, right? Well, we have our better way of defining heat. Heat is a form of energy which flows due to change in temperature or temperature difference. So, heat is brought about due to change in temperature. When you see a change in temperature, we are able to detect the presence of heat. Heat also can be generated via many sources. One of the major generators of heat energy for us here on Earth is the sun. The solar energy, which is captured here on Earth, is felt in terms of light and heat energy. It's a combination of light and heat energy which reaches us from the sun. So, the sun is one of the major suppliers of heat energy to the Earth. As well, we can also produce heat energy from chemicals. When you mix your trioxo sulfate 6 acid with some other reagents, most of the time your trioxo sulfate 6 acid is actually a hot chemical, the concentrated one. It is hot. So when you touch the body, if you pour it into your glass conical flask, you touch the body, you feel the warm temperature. Heat is always indicated by change in temperature. That's why we say heat is a form of energy that flows due to temperature change. So what is temperature itself? Since heat is related to temperature. Well, temperature is a degree of hotness or coldness of a body. It's how hot or how cold a particular body is. That's what temperature is. So a body, most times people mistake temperature for heat. But in this topic, we'll try to look more into it and see how we can differentiate between the two of them. It is possible that there is a temperature change and there is heat change, and it is also possible that there is no temperature change but heat change also occurs. That is, heat energy is being used up. Having spoken about the concept of heat and temperature, a question will pop up on your screen in a few seconds. We'd like you to attempt it and see how much of what we've taught so far you understand. Effects of heat on matter. Well, the first thing we have to understand is the issue of matter. What is matter? Well, we must have been told time without number that matter is anything that has mass and occupies space. So matter has a number of particles in it. It has its own particles and it occupies a particular space, either unlimited space or a controlled space. So, but what effects does heat have on matter? Heat can have one or all of the following effects on matter, starting with change in chemical structure, that is chemical change. For certain chemical reactions to occur, a certain degree of heat energy needs to be applied. So when this heat energy is applied, it enhances the chemical reaction, or rather, sometimes it actually allows the chemical reaction process to take place. Also, heat energy can also result in physical change. It can also result in physical change. Certain items, certain chemicals, when exposed to heat, change in their appearance. The properties of those chemicals they are altered. For instance, your gold. When you heat your gold, it melts. Even before it gets to that point of it melting, it begins to have some changes in its appearance, in its physical appearance. So this occurs with almost every chemical you can think about, every matter, every substance you can think about. Apart from physical changes, you can also experience temperature change. Of course, when you apply heat to a certain region, you can feel it. We've talked about temperature being the degree of hotness or coldness of a particular thing. As well, we have change of states. Yes, when we're talking about change of state of matter of a thing, when we talk about state of matter of a thing, it means whether it is a solid, in a solid state, it is in a liquid state, or in the gaseous state. Just like when you have your eyes, if you take your eyes and you put it on the heat, it melts. It changes state from solid to liquid. And if you keep that water on the heat after it has melted completely, you see it start to vaporize, and soon you have an empty pot, which is another change of state from liquid to the gaseous state. Another effect of matter, another effect of temperature on matter is expansion. Expansion of the bodies. When heat is applied on a plastic material, the plastic material begins to melt and begins to increase in size. The same thing happens to metals. Even when they don't melt, they stretch before they get to the point of melting. Many of us do not observe these changes due to it. And heat energy has the property, has the capacity to alter a lot of things. Measurement of temperature. Temperature is always measured with a tool called the thermometer. The thermometers are built using thermometric liquids, usually. Though we have different kinds of thermometers. We have the liquid in glass thermometers, we have the metallic thermometers, and light thermometers. So in a future topic, we would take our time to discuss this. The kinetic molecular theory is a theory proposed that atoms in a particular, that every matter, every element, everything, every substance contains atoms and molecules. Atoms, of course, we will define very soon as the smallest part of an element that can take part in any chemical reaction, while a molecule is the smallest part of an element that can naturally exist as a whole or as a part of a thing, that is either in a compound or on its own. So the first law, it's a series of theories, a series of proposals, and the first one says that all matter are made up of atoms. These atoms are clicked together, are connected together, and these particles are in constant motion. They are in a constant state of random motion. That's what the second theory states, that they are in a constant state of random motion. And also, because they are in motion, it means they possess energy, and the energy here is kinetic energy. Since they are moving, kinetic energy is being transmitted, and of course we know energy is neither created nor destroyed. So this kinetic energy actually exerts force, attractive force on each of the atoms. Now the molecules of the material start exerting force, attractive force on each other due to the presence of this energy. And the final part of it says that the closer the atoms or the molecules are to each other, the closer the particles are to each other, the stronger the force of attraction between the molecules. So that's basically what the kinetic molecular theory. It's just a theory that states certain principles, more or less like ideologies that guide our future study when it comes to heat and matter. Thermal expansivity. Thermal expansivity has to do with how heat brings about changes in sizes of components or substances. The word thermal is used to describe heat, while the word expansivity talks about something changing in size, that is, it expanding, it getting bigger or smaller, as it may be. So it, of course, we talked about it in the previous chapter, that in the previous subtopic, that it causes changes in property. It also leads to expansion of items. Now, each of the elements do have their own individual thermal expansivity, and these thermal expansivities can be expressed at 3 different levels. The first is the linear expansivity, which is the expansion of that particular element or that substance in one direction. That is, in one-dimensional analysis, in one-dimensional consideration. So, the formula above here represents how we calculate the effect of linear expansivity on a substance. The formula shows this here is indicating change in length. So change in length is calculated by the formula, the linear expansivity of that particular element or substance multiplied by the length, that is the original length of the substance, multiplied by the change in temperature, that is the final temperature minus the initial temperature. You minus before you multiply it with the rest of the items. Also, we have area expansivity. Area expansivity talks about the expansion of a particular element or a material when it has to do with areas, sheets. So it's no longer one-dimensional, now it's two-dimensional. And we have the area expansivity identifier beta. The identifier beta can also be calculated from linear expansivity. So sometimes you might be asked to calculate area expansivity, the amount of the change in area, and they will give you only linear expansivity. You can get the area expansivity simply by multiplying the area expansivity by 2. So the change in area is calculated by area expansivity multiplied by the original area multiplied by the change in temperature. And same thing applies to the cubic expansivity that happens in case of objects. That's 3D considerations now. And also it is represented by the symbol gamma. Gamma is always equal to 3 alpha rather, is equal to 3 alpha. So if you are given linear expansivity, multiply it by 3 to get your volumetric or cubic expansivity, and you can use it in the formula. All the formulas are the same. The only differences we observe is volume works with gamma, areas work with beta, and lengths work with alpha. Let's take a question on thermal expansivity. The question goes thus. The linear expansivity of a material is given as 15 times 10 raised to the power minus 5 per Kelvin if the initial area is 25 meters squared. Calculate the increase in area if it is heated through 40 degrees Celsius, and also we expect to calculate the cubic expansivity. Alright, let's start from the very first question. Let's write out our parameters. What are parameters we're given? First parameter is the linear expansivity of the material, which is alpha, and it is given as 15 times 10 raised to the power of minus 5 per Kelvin. Next, we can see the area, which is given as 25 meters squared. And also we're given the change in temperature. Let's call change in temperature. Change in temperature is T2 minus T1, which is the same thing as theta, which is 40 degrees C. We expect to calculate the change in area, but we cannot calculate change in area unless we do put into consideration also our area expansivity. Area expansivity is represented with beta, and beta is always equal to 2 alphas, so which is 2 multiplied by 15 times 10 raised to the power of minus 5, which would give 30 times 10 raised to the power of minus 5 per Kelvin. Okay, so now we can introduce our formula. Our formula says change in A equals beta multiplied by original A, which is what we have up there, multiplied by T2 minus T1. Substituting our values into the expression, we will have our change in area that's to be equal to, putting our 30 times 10 raised to the power minus 5 multiplied by the new area, which is 25, multiplied by the change in temperature, which is 40 degrees Celsius. And when we multiply all of this together, we'll find out, get our change in area to be equal to 0.3 meters squared. And to answer the second question is on calculating the cubic expansivity of the material. Of course, we know our cubic expansivity is represented by gamma, which is always equal to 3 alphas. So multiplying, substituting our value for alpha into the equation, we have 3 multiplied by 15 times 10 raised to the power minus 5 per Kelvin, and that would give us our gamma to be equal to 45 times 10 raised to the power minus 5 per Kelvin. We can leave our answer like this, or we can simply take it to the nearest submultiple. I would prefer to bring it to micro, or let's bring it to milli. That's 10 raised to the power minus 3. So bring it to milli, it will be gamma equals 0.45 times 10 raised to the power of minus 3. So that's the expression we get. Now, what are the uses, the applications of thermal expansivity? Application of thermal expansivity as seen in the construction of bridges. Gaps are left in between bridges, that is in between the concretes used in building, in the construction of bridges. And why are those gaps left? So that when the concrete is heated up and it expands, it will have a space to expand and avoid the cracking of the bridges, resulting in the destruction or early collapsing of the bridges. Also, we see the application of thermal expansivity in control valves, control gauges used in our pressing irons, or generally heat controlled switches. We see them in the use of bimetal strips, which actually use heating to control temperature ranges, or to control the switch of a particular item. Earlier, when we were discussing the effect of heat on matter, we mentioned that heat can also bring about the change in state of a substance. Well, how does this happen? In the course of changing state of a substance, it is always observed that the temperature at which that substance changes the state remains constant while the substance changes state, either from solid to liquid, liquid to gas, gas to solid, gas to liquid, and liquid to solid. In other words, what I'm trying to say in essence is that if you are cooling water, or you are heating water rather, and you keep boiling the water, when it gets to 100 degrees Celsius, it stays at 100 degrees Celsius and the water begins to evaporate until the water has completely evaporated before the temperature would change. This is the reason why the amount of heat used to convert a particular substance from one form, that is one state, to another, is described as the latent heat. Latent heat, the word latent comes from, is a word of the The words latent heat simply refers to the heat required to convert the state of a particular substance from one form to another without bringing about temperature change. So we usually have two types of latent heat. We have latent heat of fusion, which is the heat required to convert a liquid to a solid or solid to liquid without a change in temperature, while latent heat of vaporization is a heat required to convert a liquid to gas or gas to liquid without an increase in temperature. Heat transfer. When we talk about heat transfer, we talk about the movement of heat from one place to another, or the transmission of heat from one point to another. So earlier we talked about energy not being created nor destroyed, but can be transmitted or transformed from one form to another. But this time around, it is not being transformed, it's just being transferred. It's being moved from one place to another, probably for it to be used for a particular purpose in the new location or being lost. So, how do we transfer energy? Heat energy specifically. There are three means by which you can transfer heat energy. These are conduction, convection, and radiation. Conduction is a kind of heat transfer that involves physical contact between a solid and the source of heat. When we talk about solid and source of heat, the solid which makes physical contact with the source of heat and transmits this heat to another place is known as the conductor, while a solid which does not allow heat to pass through it is regarded as an insulator. Of course, conductors are very, very important. They are used in conduction of heat from one point to another. That's in designs where we need heat to be moved. And also they are also used to store heat over a certain duration. Now we can talk about convection. Convection is the transfer of heat through a fluid. Fluid referred to liquids or gases. So this does not actually require direct contact with the source of heat. But once the fluid touches the source of heat, it carries the heat and transmits it to where it is needed. Now, convection occurs in liquids and gases, both of them. And also we have radiation. Radiation events occur without use or without a medium of transmission. It occurs, the radiation waves, the radiation is carried via waves. That is, it's transmitted via waves. So once those waves are able to float across, they get to their destinations. Examples of conduction in process is when you put your plate, your pot on the hot plate or on the gas cooker. Your pot gets hot from the heat coming from the burner of your gas cooker, and it directs that heat into the pot to the food that is being cooked. That is a direct, because there is physical contact between the food and the pot, physical contact between the pot and the flame. A good example of the convection heat transfer is a operation of your fan. Your fan blows cool air at you. That's why when the cool air touches you, you feel the breeze, you feel the coolness of the atmosphere. And of course, a very good example of radiation in effect is the sun. The outer space is full of vacuum, is occupied by vacuum, which means it is unoccupied. But the radiation allows the sun rays to heat up the earth. Now, there's a very good example, which is a thermos flask, that talks about how to prevent each of these transmission from occurring. On certain occasions, we don't want our heat to move, probably because we don't want it to waste. For example, you boil water and you want to save it for maybe a couple of hours. So what do we need to put in place? to prevent this heat from being lost. A very good description of what can prevent it is found in the thermos flask. The thermos flask contains several items. The ones that stop the conduction process from occurring are the corks. Corks are insulators. They are solids and they do not allow heat to pass through them. So they prevent heat from coming out of the flask. The next thing we have there is the vacuum that is being pumped into the glass tube where the water is being accommodated, or the liquid is being accommodated. The vacuum inside the glass tube prevents its transfer via convection rather. Since there is a vacuum, which means that the air blowing or the fluid within, since there is no fluid within the glass tube, then there is no way through which the heat transferred via conduction can pass through. And finally, we have the silver coatings on the inner layer of the thermos flask. This silver coating prevents heat transfer via radiation. Since radiation is via waves, the reflection returns every time of heat trying to move out via radiation back into the flask. In this topic, we talked about the concept of heat and temperature, and we discussed temperature as the degree of hotness or coldness of a body. We talked about it as the energy, a form of energy, which flows due to temperature change. We also discussed the effects of heat on matter, and we mentioned effects as chemical change, change in physical properties, change in states of the matter, and also expansion of the matter. We discussed how to measure temperature, and we mentioned that temperature is measured using thermometers of different kinds, and these thermometers are developed based on the thermometric properties that they do have. We talked about the kinetic molecular theory, which has 5 different points listed on it. And the first point states that matter is made up of atoms or molecules. These are the particles that make up matter. And the second one says that these particles are in constant random motion. The third one says because they are in motion, they possess kinetic energy. And fourth says that this kinetic energy creates a binding force, a force of attraction between the molecules. The fifth one says that the closer the atoms are to each other, the closer the particles are to each other, the stronger the force of attraction that exists between them. Then we moved on to talk about thermal expansivity, and we described thermal expansivity as expansion of a particular component due to heat change, due to temperature change. I mentioned that we have 3 different types of thermal expansivity. There's a linear, which has to do with the one-dimensional consideration of thermal expansivity. We have the area, which has to do with 2-dimensional, that is length and breadth, expansion of substances. And we also consider the volumetric, which is also called the cubic expansivity, which talks about the 3D expansion of substances. We also considered change of state. In change of state, we talked about heat. We talked about latent heat. Latent heat as hidden heat, which is a heat which is not felt in terms of temperature change, but actually causes change of state of matter. And we concluded by talking about heat transfer. We mentioned that there are 3 methods of heat transfer. These are conduction, convection, and radiation. Conduction is done via physical contact of a solid material with the source of heat. Convection convection takes place when a fluid, a liquid or a gas, flows over the source of heat and moves this heat to another location, while radiation occurs without any medium. it transfers this heat via waves. In a few seconds, some questions will pop up on your screen. Please do attempt them, and if there is anything you do not understand, you can go over this video once again. Thank you for your time.